Hello everyone, my name is Joel Lodra.
My name is Nathan.
My name is Stefano.
My name is Satria.
We are from Team Young Baller. Today, we are going to do a presentation regarding the implementation of our disassembler and show a short demo using a given task file that we have modified. Without further ado, I'm going to give the mic to Nathan, who will further explain about how our program works through a flowchart.
As you can see, this is the flowchart for our disassembler program. We try to modularize the program by separating the flowchart into smaller sections and assigning one or more members to focus on each section. The first thing to do is getting the user input. To get the correct input, the program must go through a series of requirements twice for both the starting and ending addresses. After getting all the inputs, the program will do a final check which requires the ending address must be greater than the starting address. After that, the program will enter the disassembling loop, which will read the machine codes and display to the console as the program goes. The disassembling loop will continue until the program reaches the ending address. Then it is up to the user to restart the program or exit it. Next up, Estefano will talk about all the opcodes and addressing modes that we have completed.
I'll be talking about the completed opcodes and addressing modes, as well as the process for mapping binary instructions to opcode words. For the opcodes, we decided to group them based on common bits, so the comparison can be easier and simple. First, we take the first 4 bits of the word address and compare that to the current opcodes 4 bits. If they're not valid, then we move on to the next opcode. If there's a match, we continue to read the next bits through bit masks and then handle each case separately. For the addressing modes, we made a subroutine that classifies each addressing mode given the state of the mode, whether it's a destination or a source, as well as the opcode word. In the case of an invalid instruction, we print out the given data in the required format. Now for incomplete work, we have successfully completed all the assigned work, including opcodes and addressing modes. However, we still have several bugs that we cannot fix.
Throughout the quarter, we have been trying our best to smoothly finish the implementation, but problems always occur. One of the most significant problems that we encountered throughout the quarter was the time zone differences between the United States and Indonesia, with Indonesia having 15 hours ahead. Me and Joy are currently in Indonesia, whereas Nathan and Stefano are in the United States. It was difficult for us to set up meetings and communicate with each other, as me and Joy are currently in Indonesia. Moreover, we took too much time planning for the implementation and waited too long to start implementing. We went pretty slow, but we then sped up our work and changed our strategies of implementation so it could be more efficient. We found 2 different bugs that we still don't know how to fix yet, but we will continue testing and fixing these bugs until the submission day of the disassembler. As you can see in the slide, the first bug is that our disassembler program always detects MUL as having sized word. MUL size will always be 1, no matter what we put in the test file. This error also occurred when we tried to run the test file. We assumed that the simulator is not compatible with the long slice, so we decided this behavior was reasonable. Another bug that we found was about move-m incorrect grouping address and data register output. This screenshot shows it all. We are not sure how to exactly display the specific output for the grouping address, so we decided to print out everything individually with slashes. Now Joy is going to show the demo of our disassembler program that we have been implemented.
So yeah, right now I'm going to show you guys a short demo of our disassembler program. So as you guys can see here in the screen, this is our testing file that we've already modified, and it's starting from address 9000. Okay, let's just get right into it. Run, execute, and then I'm gonna load the testing file by clicking file and then open data, and then I'm gonna click this test.s68. So now it should be loaded into the memory. I'm gonna show you guys the view of the memory. So yeah, as you guys can see here, starting from address 9000, it's already loaded with memories, meaning that the testing file has been loaded into the memory. And then yeah, I'm gonna run it right now. On the console here, we've already given a clear instruction to the user about the right input. So yeah, let's just start reading the file. So starting from address 9000, and then the ending address, I think it's around 9000-9350. So the first time we click the ending address, it's gonna show up like around 15 opcodes, because like we want to show everything. And then press enter, it's gonna clear the previous screen, and then it's gonna show another 25 opcodes. And then when I press enter again, it's gonna clear the previous screen, and it's gonna show another 25 opcodes. We want to do it this way because we want to do it like each 25 opcodes, because we want to show everything in a single screen. And then as you guys can see here, this is the move opcode. We still haven't figured out how to fix it yet. And then I'm just gonna click enter, 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 enter. At the end of the program, it's gonna give a message, this is assembling finished, and then press R to restart and the keys to stop. So let's try to restart. So I'm gonna press R. Okay, it's gonna return back to it's gonna bring me back to the first input. $9,000. Yeah, press any key to stop. Yeah, I think that's about it. Thank you guys.